Everybody, it's Dr. D. So in this video, I am going to be talking about how you plan and how you should consider planning for math instruction. So if you've watched my earlier videos, you've seen how I unpack a math standard. You select that standard and you identify the content knowledge, or what people identify as the nouns, and your skills, which are what students are going to be doing, or the verbs. So you can see here I've selected a third grade operations and algebraic thinking standard. It has to do with multiplication. In this standard here, I've identified the knowledge, the content knowledge of this standard, which are products, whole numbers, and I've also put in equal groups because students need to know that. It's a foundational skill for understanding multiplication. And as you can see, instead of interpret products, that's something that's very impossible for students for me to be able to see. So I've changed that vague verb to explain. So if you want to know more about some of those terminologies and vague verbs and how you can change them so that you can really focus in on a learning objective and outcome, check out my other video. I've changed the verb here because explain is something that I can observe. Explain is something that I can see, whether students are writing or they're doing or I'm asking them questions. Now, once I've unpacked that standard, I'm going to go ahead and look at what the learning progression says about this particular standard. Again, those learning progressions are the documents that really help us identify what prior knowledge and skills my students should have so that they can master the standard. So here's a hyperlink here. It's going to take me right into that Achieve the Core website for this particular standard, third grade operations and algebraic thinking. And I can see this is a major cluster, and here are some of the standards from previous grades that support students in this standard. So working with equal groups, which is why I put that in there, is the content knowledge. Students need to know about equal groups for them to understand multiplication. All right, going back, so you can check that out. I wrote down what is the learning progression. And I've also stated that students should be able to model and draw equal groups to find how many in all. Now that I've done that, I can start thinking about some strategies that my students might come up with based on their prior knowledge, and maybe some models that I want to explicitly teach to support them in this standard. So I've identified several strategies here. One is with students making groups of objects and saying 5 groups of 4. So they've drawn 5 groups and they've put 4 in each group. I've also identified an array, which is an important foundation for multiplication. It also is supported with geometry standards and will help when students get to upper elementary and have to do area and surface area and things like that. Students might also use a number line. This is kind of an entryway into multiplication because they're using a skill like skip counting. So you can see here, students are skip counting by 4s 5 times. Similarly, repeated addition is one of those entryways. And then we might be able to bring in some of those underlying principles like the commutative property or even distributive property for students to understand how to make that, how to build on that algebraically. Because remember, the domain is operations and algebraic thinking. Here I'm going to build on the 5 representations. So the 5 representations comes from Van de Waal's work, where essentially we want to make sure that students are getting access and experiences in each of these representations in order for them to really demonstrate mastery of the standard. So while I'm thinking about planning, I'm also thinking about what I can do with physical representation. So maybe my students are using counters and they're creating and solving. Maybe I'm having my students, I should, not just maybe, but visual, right? Students are drawing those visual representations. Verbal, this is where my ELD standards can come into play, my standards for mathematical practice. I want my students to be able to construct a viable argument about a context for multiplication expressions. Symbolic, students are going to write multiplication expressions to represent a context. And contextual, they are going to create a word problem for a multiplication equation. Notice that there's kind of this higher level of academic rigor that's becoming increasingly more complex. And so we could look at Bloom's, but we know Bloom's is here as well, that taxonomy of increasing the cognitive demand. Now that I've kind of fleshed out what I would want my students to be doing, what I would want to make sure that I'm doing in my teaching practice, I can write a learning objective. It kind of flows nicely this way once I've fleshed everything out and kind of identified what I'm looking for, what I want my students to be doing. So the learning objective for this particular standard would be to recognize and represent a context for multiplication expression in order to determine the product and know when multiplication can be used. So they have the understanding, they have the knowledge, and the skill in this learning objective. Here are just a few activities that I came up with. Students will write a multiplication expression to represent a picture. So maybe I'll do some pictures. They'll see that on a slide deck and they'll write that multiplication expression. Maybe they'll roll 2 dice and draw a visual model. So if you're familiar with that game, Circles and Stars, they roll 2 dice, then they write their factors, and then they find their product. And use a number line. So this is a great strategy for my students that are struggling with the conceptual. They can use that number line to skip count multiplication problems. But even if they're not struggling, remember, we always want to build in multiple representations and models because that is what builds flexibility and leads to fluency. Flexibility equals fluency. And then that creation space, that's that higher level cognitive demand. Students will create a multiplication problem and show the product using 2 or more strategies. Now that I've thought about some activities, and again, these could change based on what my students are able to do and not do, and who my learners are, I can think about some of the standards for mathematical practice. Ones that I thought about based on the activities, my objective, and those representations is reason abstractly and quantitatively. That certainly ties into them building and constructing multiplication expressions and finding that product. Constructing viable arguments. So they are creating these contexts. We want them to be able to explain with reasoning and justify their thinking. And then attending to precision. So this is that language piece. When we talk about writing a multiplication equation or an expression, we want our students to be able to identify what each digit, what each symbol represents there. So we want to make sure that we also focus on academic language. See how that flows nicely? Here's the academic language that I've identified for this particular standard and for the activities and what I would need to make sure that my students have that understanding. And here's just a few ways that I can meet that language demand. My students are constructing an argument. How can I front load that language? How can I provide a visual representation of that language so that my students can use the language, right? Because ultimately we want our students to use the language. So maybe we include things like a sentence strip to help scaffold. Cultural responsiveness is also an important piece to consider. This really ties into the idea of who are my learners and what funds of knowledge do they bring into the classroom. So this could be their interests, this could be their culture, their family experiences, things like that. Really want to dive into like an asset-based approach when we think about designing instruction based on our learners' assets. And certainly connecting to their knowledge. I know typically we can use their names and the problems, but also using things that they're familiar with to help transfer learning. And just a few ways that I might build assessment. A lot of these activities, students are going to be acting, they're going to be moving, they're going to be recording. They are the music makers, right? They are making the action happen. So assessment might be having the students, when they're playing that game with the dice, record their multiplication expressions. Having them work with a partner so that they're engaging in math talk and I'm observing and hearing what they use authentically. Using an exit ticket at the end of the lesson to determine what student strategies do my students have? Where do they feel confident? So maybe I'll have them reflect and think about their level of confidence. Then I might include digital assessment tools that are already available at my school site. So maybe using something like Go Math or iReady. All right, technology is always important. And we want, even if our students are using those concrete counters or tools, integrate visual representation, integrate virtual manipulatives, so the students have those experiences using digital tools, making representations. And then with technology, we can do things like having our students record themselves and having them use that math talk. And they can listen to themselves and they can reflect and they can improve and revise. And certainly that's hard to do with a class of 30 students, but it's much more easier and accessible and promising when we have our students use devices to record their thinking and share. Always important to think about how you can connect your content knowledge across the curriculum, because we know that's where the transfer happens. And so for this particular lesson, I thought, hey, it'd be great to actually incorporate some art in having our students create tile mosaics using rectangular arrays, and then having them write about their multiplication equations. All right, well, this is my unpacking of the lesson. Feel free to leave a comment, check out this template in the comment section and grab it, use it, and share what you're doing.